Understanding Wernicke's area. Function, damage, and behavioral applications. An exploration of the significance of Wernicke's area in language processing and its impact on behavior. The Wernicke's area is a vital brain region essential for language comprehension, enabling human communication as we know it today. It allows us not only to recognize sounds as language, but to attach meaning and intention and nuance into what we hear. The Wernicke's area was first discovered in 1874 by a German neurologist Karl Wernicke during his study of patients with aphasia. He's inspired by the earlier work of Pierre Paul Broca and was able to localize the cause of his patients to a small area of the brain, which he humbly named after himself, much like Broca. At the time, the theory of holism was still a popular view in the field, suggesting that cognitive functions were spread throughout the entire brain. Wernicke's discovery provided strong evidence for the competing theory of localization, showing that highly specific regions supported highly specific functions. This was a major turning point in neuroscience and shaped the foundation of modern neuroanatomy. Wernicke's area is located in Brodmann area 22 in the posterior part of the superior temporal lobe in the dominant hemisphere. For 95% of people, this is the left dominant hemisphere. Its proximity to the auditory cortex allows for efficient processing of language-related auditory information we constantly receive, making it essential for day-to-day comprehension. Without this close anatomical relationship, the brain would have to work much harder to interpret speech as quickly as we do. The Wernicke's area plays a significant role in our understanding of language. Its main roles include identifying speech sounds and organizing them by detecting phonemes and matching them with word patterns we know. Using context to understand the meaning of identified words. Linking words to their meaning and connotation, which helps us understand nuances, metaphors, and double meanings. Converting symbols, such as written letters or signs, into meaningful language. Coordinating with the Broca's area to create fluid language use, monitoring and correcting speech mistakes in real time. A major part of this coordination is made possible by the arcuate fasciculus, which acts as a communication bridge between the Broca's area and Wernicke's area. Wernicke's area interprets incoming information, then sends that process meaning to the Broca's area so it can be applied in speech production. This pathway allows us to listen, understand, and respond seamlessly in conversation. When this connection is interrupted, even if both regions are intact, people may struggle to repeat words or sentences accurately. Individuals with damage to the Wernicke's area often experience receptive aphasia, which may best be described as the inability to comprehend or meaningfully express written or spoken language. These patients typically have fluent, effortless speech, but often lack meaning in what they're saying, speaking nonsensical phrases. Additionally, the patient often has auditory incomprehension, meaning they cannot understand what is being spoken to them, despite hearing it normally. Finally, patients are often unaware of their lack of comprehension, making it a particularly challenging condition. Kanzi is a famously intelligent bonobo who excels in displaying several key behaviors we can thank the Wernicke's area for in humans. Under the care of researchers, Kanzi was able to recognize and understand written words, allowing him to communicate through the lexigram boards shown in this picture. He was also able to understand and interpret spoken instruction using context, allowing researchers to communicate with him to do tasks like gathering wood and building fires. These abilities gave researchers an opportunity to explore which aspects of human language are shared with other primates and which are uniquely tied to brain structures such as the Wernicke's area. His skills not only highlight the cognitive potential of our closest relatives, but the evolutionary roots of comprehension. In summary, the Wernicke's area is critical for facilitating language comprehension and processing. Its roles in communication emphasize the evolutionary significance of language and offers an insight into how language functions may have developed in species closely related to us. Understanding this brain region not only helps us appreciate the complexity of human communication, but deepens our understanding of the biological foundations of language itself.